Hello students, നമ്മൾ ഫോർമുലയായിട്ട് ഗ്രീൻസ് തിയറം ഡിസ്കസ് ചെയ്യാം. ഗ്രീൻസ് തിയറം in the plane. So suppose f is equal to mi plus nj is a vector field in the plane. So you have the plane, this is x-axis, this is y-axis, and f is defined in the plane or at least in some domain. Domain I have not mentioned here. Okay, this is the domain of f. D for domain of f. And let C be a closed contour counterclockwise. Closed contour traversed counterclockwise. Traversed counterclockwise. So I have mentioned that the motion is counterclockwise by using this arrow like this. Then recall flux is given by the formula integral over C f dot n ds. This is a line integral. And recall circulation. So these are definitions. We have already defined flux to be the integral of the component of f in the normal direction. So what is n? N is outward normal. So at this point this is n. At this point this is n. F dot n ds, and Green proved that this flux is equal to flux is related with divergence. So double integral dou m by dou x plus dou n by dou y dx dy. So flux and this is divergence. Flux is related with divergence. So this is what Green proved first, and then he proved that circulation, that is given by the formula recalled integral over C f dot t ds. So what is t? It is the tangent vector. So at this point let us say t is like this. So circulation is given by the line integral of the component of f in the tangential direction with respect to the arc length. Integral with respect to the arc length. And Green proved that this is equal to the double integral of curl of f. So what is curl of f? Dou n by dou x minus dou m by dou y dx dy. So this is precisely the curl of f. Okay, so now so here double integral comes into picture. So double integral with respect double integral means you have a region enclosed. So what is that enclosed region? It is precisely the region enclosed by C. The region enclosed by C. So it will be denoted by R. Double integral over R. Here also it is double integral over R. So what is R? R is this region. R is this region enclosed by C. C is the curve and R is the region enclosed by C. So this is your R. So Green proved that flux is equal to double integral over R. So this is outward flux. Outward flux is equal to double integral. That means n. The normal vector is directed outwards. Outward flux is equal to double integral of the divergence. And circulation is equal to double integral of the curl of f. we shall do one or two examples. Verify both forms of Green's theorem. Verify both forms of Green's theorem, that means theorem 1 and 2. Green's theorem for the function vector f equal to x minus y vector I plus x times vector j, and the region R enclosed by the unit circle, and the region R enclosed by the unit circle C given by vector R of t equal to cos t vector I plus sin t vector j sin t vector j 0 less than or equal to t less than or equal to 2 pi. Okay. So here you are asked to verify Green's theorem. So let us draw this figure. This is the unit circle. So this is the unit circle, cos t vector I plus sin t vector j. This is the interval 0 to 2 pi. So what is vector t? Okay, so we have to find what are the things we need to find. We need to find the integral f dot n ds. This is the same as okay, this is the thing we have to find out. Another thing we have to find out is double integral over r. This is integral over c. This is double integral over r. What is r? The area enclosed by the unit circle. The region enclosed by the unit circle is r. This is your c. This you have to find out. Dou m by dou x plus dou n by dou y dx dy, and Green's theorem says that these two are equal. So I have to verify, I have to find out this value, and check whether they are equal or not. Okay, so this is one form of Green's theorem. Now what is the other form? Let us write 1 dash and 2 dash. In 1 dash I have to find out integral over c f dot t ds, and in 2 dash I have to find out double integral over r dou n by dou x minus dou m by dou y dx dy. These two values you have to separately find out and check whether they are equal. Okay, so let us find out the value of 1. What is 1? Integral over c f dot n ds. This we have to find out. So we should know what is n. So what is r of t? It is cos t vector I plus sin t vector j. Now what is v of t? Velocity. So it is r dot t. Dot means differentiation with respect to t. So this is minus sin t vector I plus cos t vector j. Okay. Now what is n? Oh no. What is n? So rotate the velocity vector. Okay, is this a capital T? Is this unit vector? Yes, because square root of sin square plus cos square is equal to 1. So this is a unit vector, so the unit tangent vector is this. Now how do you obtain n? It is obtained as revolve t counterclockwise by an angle pi by 2. So how do you get that vector? Interchange the coordinates and change the sign of one of the coordinates. So cos t vector j, which sign? Okay, let me explain. So this is the point x comma y. That means the vector xi plus yj, and I want to get a vector perpendicular to this. So this is one choice, and this is another choice. Both are perpendicular to this. So how do I get this vector? So interchange y and x, and put a minus sign in the first place. So if this is 1 comma 1, then this vector will be minus 1 comma 1. And how do I get this vector? Interchange the coordinates. 1 and 1 you interchange. Again you will get 1 and 1, and put a negative sign in the second place. So this is going to be 1 comma minus 1. You understand? So similarly here for this vector sin minus sin t vector I plus cos t vector j, I want to get a vector perpendicular to vector t. So how do you get? Interchange the coordinates, then you can change one of the sign. Which one? So to get a unit vector perpendicular to vector t by rotating t through an angle pi by 2 counterclockwise, you change the sign of the first place here like this. So minus cos t vector j minus sin t vector I. Okay. Now you can find out f dot n ds. Integral f dot n ds, s for arc length, small s. So how do I do that? Okay, recall this is by computation which we have proved already. This is integral over c, m dy minus n dx. m dy minus n dx. So this is equal to integral over c becomes integral 0 to 2 pi. What is m? What is m? This is your m. This is your n. So m is x minus y. What is x? Cos t. What is y? Sin t along the curve c. So cos t minus sin t. So cos t minus sin t times dy. So what is x of t? X of t was cos t and y of t was sin t. So dy is cos t dt dt I will write later minus n times. What is n? N is x. And what is x? X along the curve, which is cos t. Sorry, n. N is, yes, n is cos, right? Yes. N is x and x is cos t. Cos t into what is dx? What is x of t? It is cos t. So dx is minus sin t dt. So here it becomes plus sin t whole into dt. I hope you understood. So what you will get? So here minus sin t cos t and plus sin t cos t cancel. So here you are left with integral 0 to 2 pi cos square t dt. So this is equal to integral 0 to 2 pi 1 plus cos 2t divided by 2 dt, which is equal to 1 by 2 into t plus sin 2t divided by 2 between 0 to 2 pi. So what you will get? 1 by 2 into 2 pi plus sin in the upper limit. Sin 4 pi is 0. And in the lower limit 0 plus 0. So it is 2 pi simply. So it is 1 by 2 into 2 pi equal to pi. So this is the LHS. Named our 1. Now what is our 2? What is our 2? Green's theorem says that this must be equal to double integral over r dou m by dou x plus dou n by dou y. This is the divergence dx dy. Okay. So we have to compute this thing and see what is the answer. So this is equal to double integral over r. What is dou m by dou x? What is m? X minus y. M is x minus y and n is x. So what is dou m by dou x? It is 1 plus what is dou n by dou y? It is 0. Dx dy. What is r? Interior of the circle. So simply you have double integral over r dx dy, which is the same as area enclosed by r. And what is this? Area enclosed by the unit circle. What is that? Pi into radius square. But radius is 1. So it is pi. So LHS, namely 1 equal to 2. So Green's theorem is verified in the first case. The other part you do as homework. Which part? 1 dash is equal to 2 dash. This verification you do as homework. Thank you.